level mathematics differentiation. This is the question from implicit differentiation. It's implicit differentiation. Now,
Solve all your doubts on A-Level Insight Plus.
let's do this. 3x squared plus 4xy plus 3y squared equals 5. First of all, differentiating both sides with respect to x. We can do d over dx, 3x squared plus d over dx, 4xy plus d over dx, 3y squared equals d over dx, 5. Uh, we can say that and the derivative of a constant or the derivative of 5 is 0. So this is 0. The derivative of 3x square is 3 times 2x because we do not need to differentiate 3. We only need to differentiate x square, which is 2x. So now plus uh, here we have a function with two different variables. So first let us use product rule, then we will differentiate this. But first let's bring this 4 out. Now it's d over dx xy plus d over dx 3y squared. Now 6x plus 4. Let's use product rule, which says that d over dx uv is u dv over dx plus v du over dx. Simply this. So it's like d over dx x times y plus x times d over dx. This is product rule plus. Let's copy this as it is for right now. 3y squared plus 0. Now, now let's differentiate these y terms. 6x plus 4 times the derivative of x is 1, so 1 times y is y plus. Now we need to differentiate this y, but we have d over dx here, so we cannot do it directly. So we need to use the chain rule here. Let's apply chain rule. When we apply chain rule, we can write this down as d over dy inside the bracket y times dy over dx. What this does is we can cancel this dy on the numerator and denominator. So this expression becomes what it was on the previous step. So we can clearly do this. So now we can easily differentiate this. Likewise, we're going to do the same for this one. We can do this as d over dy 3y squared times dy over dx because we're using chain rule, because this dy and dy can simply get cancelled. So now after this step, it's like 6x plus 4 times we have y plus on the derivative of y with respect to y is 1. So it's x times 1 times this dy over dx plus we have derivative of 3y square, which is 3 times 2y times dy over dx equals 0. So now it becomes 6x plus 4y plus 4x times dy over dx plus 3 times 2 is 6 y times dy over dx. Now, the work is almost done. Now we need to separate them. Let us separate this dy and dy over dx on a different side. First, let's see what we need in the question. We need this expression, right? So, first, let's send these two on the other side. Let's take dy over dx common. We get 4x plus 6y. And when we send these on the other side, we get minus 6x minus 4y. Now, let us send this downside. We get dy over dx equals minus 6x minus 4y divided by 4x plus 6y, which can be written as we take minus common, we write 6x plus 4y divided by 4x plus 6y. The question has asked us 3x plus 2y, 2x plus 3y. We can again take 2 common, and we can take 2 common. We can say this as 3x plus 2y divided by, we take 2 common, 2x plus 3y. We cancel these two, and finally we get 3x plus 2y over 2x plus 3y, and of course there's a minus sign in front of this expression. This is the solution. We've already solved the part A, which tells us to find the expression which gives us the gradient of the curve. Now, in part B, we need to find the exact coordinates of 2 points on the curve at which the tangent is parallel to y plus 2x equals 0. What this means is, let's say we have a curve like this. Let's say we have a curve like this. Now, we draw tangent from 2 points. Okay, 2 points. Let's say we draw tangent from here and we draw tangent from here. These are the two tangents. Now, these two tangents are parallel to a line which is y plus 2x equals to 0. So the question has given this information. Now, from this information, we need to calculate the coordinates of these 2 points. Now, the first step is to rewrite this equation. We know that y equals minus 2x plus 0. This is in the form of y equals to mx plus c, where m is the slope or gradient of a line. So, the gradient of the line m is basically minus 2. This line I showed you, these two tangents and this line. So, the gradient of this line is minus 2. Now we need to equate this gradient with the dy by dx expression. So basically, m is dy by dx. We know that dy by dx is 3x plus 2y divided by 2x plus 3y. This equals negative 2. We got this negative sign. We have 3x plus 2y equals 4x plus 6y. Now we have x equals to minus 4y. We got a very important clue, which is we found a new equation. So let's say this as 1. Now our job is almost done. We need to substitute x in the original equation, which was 3x squared plus 4xy, which was 3x squared plus 4xy plus 3y squared equals 5. Now we put x as minus 4y. So it's like minus 4y squared plus 4 times minus 4y times y plus 3. It's y squared equals 5. Like 4 squared is 16. 16 3 is a 48. Y squared minus 4 was a 16y squared plus 3y squared is 5. If we subtract, we get 35 y squared equals to 5. We know y squared is 1 by 7. So we have two values of y, which is plus 1 over root 7. And we have minus 1 over root 7. Now, uh, we know that x is minus 4y. So x is minus 4 1 over root 7. X is minus of minus, it's like minus 4 times minus 1 over root 7 is x equals to minus 4 over, it's like x equals to minus 4 over root 7. It's like x equals to plus 4 over root 7. So hence the two coordinates are 4 over minus 4 over root 7 comma 1 over root 7. Let's name this as a or any other variable, and the next coordinate is 4 over root 7 comma minus 1 over root 7. Uh, this is the answer to the part B of this question, where we were asked to find the exact coordinates of 2 points on the curve. Yeah, this is the answer. Thank you for watching this video. If you have any doubt, please let us know on the comments. Thank you.